So now we are going to learn about streaming stored audios and videos. So we have three ways of streaming stored audios and videos. The first one is by using a web server. So a compressed video or audio file can be downloaded as a text file, and the browser can use the services of HTTP and send a GET message to download the file. And then the web browser can send the compressed file to the browser, and the browser can play it with the help of a media player. But however, there is a drawback to it. An audio or video file is usually very large even after compression. So it may contain 10 MB of space, or it may contain hundreds of MBs of space, and it may take a lot of time to download. And in this approach, the file needs to be downloaded completely before it can be played. So that's a little drawback. That's why we are using the second method, which is using a web server but with a meta file. So in this approach, the media player is directly connected to the web server for downloading the audio or video file, and the web server stores two files: the actual audio or video file and a meta file that holds its information. And again, this also has a drawback. The problem with the second approach is that the browser and a media player both use the services of HTTP, and HTTP was designed to run over TCP. And in this if we get any error in TCP, it has error controlling mechanisms. So it will go back, reset the error, do whatever it wants, and then give us the file again. And we don't want that. We want a UDP protocol. Even if there is any error, it's okay, we can download it again. So, but however, HTTP, which accesses the web server, and the web server itself are designed for TCP. So therefore we need another server which is known as a media server, which works on UDP. So we don't have to go back again and again to control the error. And now let's learn about streaming live audio and video. So streaming audio and video is similar to the broadcasting of audio and video by radio and TV stations. But instead of broadcasting it to the ear, the stations broadcast through the internet. But there is still much progress to be made in this area. It's still not fully developed. And that's why we are still on the verge of getting the best out of it. Now let's move on to characteristics of real-time interactive audio and video. So in real-time interactive audio and video, people communicate with each other in real time. And the internet, for example, the voice over IP is an example of its application, and video conferencing is another example that allows people to communicate with each other. And there are 6 characters of real-time interactive audio and video. The first one is time relationship. So a real-time data on packet switching network requires the preservation of time relationship between the packets of a session. What does it mean, yaar? Just tell me that. So if we can see here, a server is sending something to the client. So the first packet is sent at 0 and then received at 1. The second packet is sent at 10 and received at 11. The third 20, 21, 30, 31. Although there is a 1 second time difference between what the server is sending and what the client sees, the action is happening in real time, and the time relationship between the packet is preserved. But what if there's a difference of, like, in the first packet it's again 1 second, the second packet it takes about 5 seconds, and the third packet takes about 3, the fourth about 7, and whatnot. That's called jitter, and that's a problem. So how do we solve it? So that's why we have timestamp. So one solution to jitter is the use of a timestamp. So if each packet has a timestamp that shows the time it was produced relative to its previous packet, then the receiver can add the time at which it started the playback. In other words, the receiver knows when each packet is to be played. And then we have the third character, which is playback buffer. So to be able to separate the arrival time from the playback time, we need a buffer to store the data until they are played back. So the buffer is referred to as playback buffer. So when a session begins, when the first bit of the data arrives, the receiver delays the playing of the data until a threshold is reached. So this means that we have a threshold. We have a threshold of some packets or some seconds, that when we receive this much amount of packets, then we will start the playback. Like I have a threshold of 3 packets. Then when I will have received 3 packets, only then I will start the playback. Until then, every packet is stored in a buffer. That's what it's called, playback buffer. And then we have ordering. So in addition to time relationship information and timestamps for real-time traffic, one more feature is needed. So we need a sequence number for each packet, like 1, 2, 3, 4, 5, the number of packets. And the timestamp alone cannot inform the receiver if a packet is lost. So we must do indexing, because of indexing, we will get to know if we have lost any packet. Like we have received 1, 2, 3, 4 is gone, and we have received 5th or 6th. But the seconds between all them, the gap between all the packets are just 1 second. But we know from ordering that packet 4 is missing. That's why ordering is very, very important. Then we have multicasting. So multimedia plays a primary role in audio and video conferencing, and the traffic can be heavy and the data are disturbed by using multicasting methods. Conferencing also requires two-way communication between the receiver and the sender. There always should be two-way communication, and real-time traffic every time needs the support of multicasting, because there should be two-way communication between the receivers and the senders. They should know that we are sending something, and the receiver should know that I am going to accept something, or I'm going to get something. And then comes the 6th character, which is translation. Sometimes real-time traffic needs translation. So a translator is a computer that can change the format of a high bandwidth video signal to a lower quality narrow bandwidth signal. So for example, to understand this, like a source is creating a high quality video signal at 5 MB per second, and it is sending it to a receiver which is having a bandwidth of even less than 1 Mbps. So what will happen? So to receive that signal, a translator is needed to decode that signal and then encode it again to a lower quality that needs less bandwidth. So these 6 were the characters of real-time interactive audio and video. And let me give you a peek that what we are going to see in the next video. We are going to learn about the protocols of real-time interactive audio and video, which are RTP protocol and RTCP protocol, and then the application of real-time interactive audio and video, which is the voice over IP. So let's meet in the next video.